Again, I am recording, but feel free to raise your hand and stop me because I could always go back and re-record. So we're going to go through every single question or every single type of question on the final exam. All right, I'm talking about the questions that we see here are almost identical to the ones on the final. So it's very important that you guys pay attention and understand this stuff. Here we go. There is a ridiculously easy question that says add the polynomial. And I think that's a typo. It should say add the polynomials. You actually have a binomial here that you're going to add another binomial with. So notice that there's a plus sign between them. So you are simply combining the negative 3x plus 9x. And if you're like, man, I don't know how to do that, you can get a calculator and go negative 3 plus 9, and that will give you 6, right? And we're talking about x's. So when you're adding, you just combine the negative 3x with the 9x, and you'll get 6x. And then you combine the number 7 plus the number negative 5. That'll be a positive 2. And there's your answer to that problem, 6x plus 2. Yay? Okay. Another way of looking at it would be like, oh, I need to distribute the plus sign. But when you distribute it there and you put a plus 9x, nothing changes. And when you put a plus in front of a minus, it's still a minus 5. So when you distribute the plus sign, nothing happens, right? Now, if it were a minus sign, then it would be changing the sign. Let's move on to another question. There's 2 of these on the test. Very simple. It says find the product. Notice that we have a binomial and a binomial, but there's no plus sign between it. There's no minus sign between it. That means that you're multiplying. So we're going to simply distribute one term at a time. There's 2 things here. We're going to distribute one of them at a time. So I want to go the first one, 4x. 4x times 3x. Well, 4 times 3 is 12, and x times x is x squared. And then you go 4x times 5. Well, 4 times 5 is 20, and it has an x on it. Now that we've already distributed the 4x, let's move on and distribute that positive 3. So positive 3 times 3x is a positive 9x, and positive 3 times positive 5 is positive 15. Super easy. After that, after distributed property, you're supposed to always try to combine any terms that are alike, and we do have like terms. We have this 20x that we could combine with the 9x. 20 plus 9 is 29, so our final answer is going to be 12x squared plus 29x plus 15. That is your answer. Moving on to the next one, really simple. We're going to be distributing again this x times that x. I don't know why this is capitalized. I apologize. X times x is x squared, and then x times negative 3 is negative 3x. After you've distributed the x, let's now distribute the number 3. 3 times x is positive 3x. 3 times negative 3 is a negative 9. And when you combine the terms that are in the middle that are alike, the negative 3 and the positive 3 eliminate, leaving you x squared minus 9 as your final answer right there. Again, 2 simple questions on the final, just multiplying and combining like terms. Now, there is some factoring questions, and there's 3 of these guys on the final. I only wrote 2 of them here. I mean, if you understand one, you're able to do all 3. But the beauty of these quadratic trinomials is that there's no number in the front. There's a 1. The a value is 1. A value is 1, b value is 24, and the c value is 63. So when there's no number in the front, you could easily set up parenthesis, 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 n, n, or whatever letter you have here. If it's an x, you put x, x. A y, put y, y. N squared, n, n. And why are we able to do this? Because n times n is n squared. And once you set up this factored form format, all you got to do is think of what times what is the c value, 63, that if you combine together is the b value, 24. And I always recommend making a list. So let's make a list of the multiples of 63. Okay, so how could I get 63? 1 times 63. And then you go 2 times. And if you don't know, try it with the calculator. Like 63 divided by 2, it doesn't work. 63 divided by 3 on a calculator will give you 21. 63 divided by 4 is not going to work. 63 divided by 5 is not going to work, right? 5 times nothing will give you 63. Divided by 6 doesn't work. Divided by 7, 7 times 9. So there's 3 possible combos here. The 1 and the 63, the 3 and the 21, the 7 and the 9. Now, of these three possible combos, which combines together to give us the middle value B, which is 24, the 3, and the 21, right? If I add 1 and 63, that's 64. That middle value is not 64. That can't be it. But right here, when I add 3 and 21, that does give me the middle value 24. So this is the right pair of numbers. I don't have to change any signs. You just put that number right there, plus 3 and plus 21. And that is the factored form of that quadratic trinomial. We're going to do the same for this one down here, but instead of n's, we have k's. We have a k here and a k there. By the way, I usually use x's, but on the final exam, there's one with n's, there's one with k's, just so you could feel very comfortable with those questions on the final, right? Anyway, again, you think what times what is the c value that if you combine together is the b value, and I always say make a list. How could you get negative 48? Well, let's start with either 1 times negative 48 or negative 1 times 48. I always go with negative 1. Negative 2 times, and if you don't know, get 48 divided by 2, that'll be 24. 48 divided by 3 is 16. 48 divided by 4 is 12. 48 divided by 5 doesn't work. 48 divided by 6 is 8. So if you do that on the calculator, you could come up with this list. Once you have a list of the multiples, now you go back and look at the list, but not thinking of multiplying, but actually thinking of combining. So if you combine 48 minus 1, that'll give you a 47. That middle term is not a 47, so that's not the pair of numbers you want. 24 take away 2 is 22. That's not 22. 16 take away 3 is 13. That's not 13. 12 take away 4 is 8. That's not 8. 8 take away 6 is 2. And we do have a 2 in the middle. So 8 take away 6, that's a good combo. But 8 take away 6 is 2, and we want a negative 2, not a positive 2. We have the right number, just the wrong sign, which means we have the right numbers, just the wrong signs. Change them. So we're going to end up with a plus 6 right there and a minus 8 right there. And that is another 2 questions on factoring quadratic trinomials when the a value is 1. It's going to be on the final. Almost identical to these, all right? Now, you might be thinking, why the heck did we even learn factoring? Why do I want, if this is a multiplication answer, why do I want to find the multiplication problem that gave me that answer? Well, it's simple because when you have an equation, like let's say you had equals 0 right here, you'd be able to factor this, and then if you have a binomial times a binomial equals 0, then you could split them and solve. Let me show you an example of that. Right here we have 2 binomials that are multiplied together, x plus 11 times x minus 3 equals 0. And the instructions say find the zeros of the equation. So one thing you need to know is what's posted on the wall right there. You need to know that when I ask you for the zeros, I'm asking you for the answers, for the solutions. Technically, even the x-intercepts or the roots, right? All these words mean the same thing. So when I say find the zeros, you want to find the answers, and we're going to use zero product property to find these answers. If you have something times something else and it equals 0, the first something, x plus 11, that could equal 0, and the second something, x minus 3, that could also equal 0. So your 2 answers, if you solve them, subtracting 11 on both sides, you get x equals negative 11, and adding 3 on both sides, you get x equals positive 3. Could you believe it? You're going to have a question like this on the final. That's like free points right there, right? You just got to remember that if you have something times something equals 0, split them and set them each equal to 0. Okay? Now, sometimes it won't be set up like this. Sometimes you have to actually factor to be able to split them and solve. So we have 2 equations. Both of these are on the final exam. On the final exam, they did use the letter M and the letter A. I usually use X's, but this is just to get you comfortable. I use the same exact variables that the final uses. So let's go with this one first because it's a quadratic trinomial. The A value is 1, which means we could do what we just practiced, right? Factoring, thinking A right there, A right there. Why could I do that? Because A times A is A squared. When there's no number in the front, you could set this up. And then how do you factor? You think what times what is the C value, negative 24, that if you combine together is a B value, negative 10. And I recommend making a list. How could you get negative 24? That's negative 1 times 24, negative 2 times 12. And if you don't know, just get a calculator and go 24 divided by 3. That'll give you an 8. 24 divided by 4, that'll give you a 6. And 24 divided by 5 is not going to work. So those are all the possible combos of multiplying 2 numbers together to give you negative 24. So then you go back and look at the list and forget about multiplying. Now you think about combining. So if you go 24 plus negative 1, 24 take away 1 is 23. That middle value is not 23. 12 take away 2 is 10. That middle value is 10, but it's a negative 10. And if I add 12 and negative 2, that's a positive 10. So I have the right number, just the wrong sign, which means I have the right numbers right here, just the wrong signs. Change that and change that, then plug them into your factored form answer format right here. The plus 2 goes right there, the minus 12 goes right there, and we have factored. However, this is not a factoring question. This is a solving question. In other words, we want some answers. We still have the equals 0 right here. By us changing this to this, we are now able to use zero product property and split them and solve. What do I mean by that? Again, if I have something times something else and it equals 0, that first something, a plus 2, that could equal 0. And a minus 12, that second something, could also equal 0. And you could get your two answers. A equals negative 2 and a equals positive 12. Okay? Anyway, this other one is a little different. And there is one exactly like this on the test, on the final. And we could say there's a perfect square term here and a perfect square term there, and it's a difference of two perfect square terms that you could factor, split, and solve. Or you could even pull out the GCF first, because there's a multiple of 4 and a multiple of 4. Or, this is what I do. Whenever I see that there's only one single variable, m squared, with no other m's, right? There is no bx term. It's ax squared. There is no bx. There is a c. There's only a single variable m. And whenever there's a single variable m or x or y, whenever there's just one of these guys, like over here, there's two of them. There's a squared and there's a. But whenever there's only one of them, you could just solve the old school way. Get the letter by itself on one side. How? By getting rid of things. How? By doing the opposite. And what you do to one side, do to the other. So check this out. If you don't want that minus 36, you could get rid of it by going plus 36. Plus 36. What do we have left? We have a 4m squared equaling 36. What does that really mean? It means 4 times m squared equals 36. So if you don't want that multiplication of 4, you could divide by 4 and divide by 4. That'll cancel it out. What do we have left? We have m squared equaling 36 divided by 4 is 9. And to get rid of the square, you could do the square root. And what you do to one side, do to the other. But remember, when you apply a square root in an equation, you have to put a plus or minus in front of your answer. And the answer is 3. So m equals plus or minus 3. In my opinion, that's the best way of solving this equation. Whenever there's only one letter, like over here, this one had 2. It has a squared and a's. Those are 2 different types of a's. You can't do this. But whenever there's only one single letter, like m squared, you could get that m by itself by doing the inverse operations, and you could solve that way. Okay. Of course, you could have also factored, split it, and solved. Would anybody like to see that? Yes. Okay. Might as well. Like, I already showed you how I would do it, right? By isolating the m. But if you wanted to, you could have, from the beginning, pulled out the GCF of 4, and you would still have the equal 0. And in the parentheses, you'd have an m squared minus 9. And then you could have also factored this m squared minus 9. That would have been an m plus 3, m minus 3. And you'd still have the 4, and you still have the equal 0. And now you could use zero product property because you have something times something times something equals 0. The first something, 4, equals 0. But that doesn't make sense because 4 doesn't equal 0. The second something, m plus 3, that could equal 0. And the third something, m minus 3, that could also equal 0. Giving you the same answers, m equals negative 3, m equals positive 3, which is the same thing as m equals plus or minus 3. So whenever I have one single letter, I like to just isolate it and get my answer. How do I isolate it? By getting rid of things. How do I get rid of things? By doing the inverse operations. And what you do to one side, do to the other. So right here we have a value of 2, which means we cannot do the parenthesis, x. We cannot do that because x times x is not 2x squared. So we need to use these steps that are posted on the wall to factor, right? So step 1 is to multiply a times c, and that'll give us negative 140. Step 2 is to make a list Make a list of the multiples of negative 140, okay? So we're going to start with negative 1 times 140, negative 2 times 70, negative 3 times, and if you don't know, try to divide 140 by 3 on the calculator. It won't work. So then you move on to negative 4. Let's see if negative 4 works. 140 times or divided by negative 4. That'll give us 35. Let me see, 140 divided by 5. That'll give us 28, so negative 5 times 28. 140 divided by 6 doesn't work. 140 divided by 7 is 20. So 7 times 20. 140 divided by 8 doesn't work. 140 divided by 9 doesn't work. 140 divided by 10, that'll be 14. So we also have negative 10 times 14. Anyway, those are all the possible combos of multiplying numbers together. By the way, I think the final exam also has the same C value, so you're going to have to come up with this list also. Okay. So which pair of numbers, when you combine them, gives you the middle value, which happens to be a negative 31? Well, right here, negative 4 plus 35, that'll be a 31. So that is the right numbers, but you got to change the signs because negative 4 plus 35 is positive 31, and we want a negative 31. So we have the right numbers, just the wrong signs. That'll be a plus 4 and a minus 35. Again, a plus 4 and a minus 35. So then we move on to the third part, which is setting this up with AX and AX, and we see that A is 2. So we have a 2X here and a 2X there. We take the pair of numbers, the positive 4 and the minus 35, and plug them into these blank spots. So that's positive 4 minus 35. And then you do the fourth step, magically divide each binomial by whatever you can. So on this first one, we could divide by 2. And if you divide 2x plus 4 by 2, that'll give you a single x plus 2. If you divide that by 2, you get that. Divide 4 by 2, you get that. We're going to do the same for the second binomial. Divide 2x by 2, you get x. Divide 35 by 2, you can't. So we're not going to do that. So it's going to stay the same. And that is your factored form answer. And of course, on your multiple choice, if they tell you factor, you're going to have 4 of these possible combo answers, right? And you could actually distribute to double check and see which one actually gives that to you. Right here, you could double check. If you did go x times 2x, you get the 2x squared. X times negative 35 is negative 35x. 2 times 2x is 4x. The negative 35x and the positive 4x will give you the middle term, negative 31x. So this is correct. Okay, we have another one right here, but this time it's an equation. Okay, it's an equation. Now, whenever it says solve and you have a quadratic trinomial, you have the option of using the quadratic formula, right? The x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. So I recommend looking at your multiple choice answers, and if your answers don't have any square roots in them, if they're nice answers, then you might as well try to factor, split, and solve with the steps that we just did, right? Multiplying a times c and so on and so on. So let me do that. Multiplying a times c is 3 times 14, and that is 42. Okay, and then you think of the multiples of 42 that combine together to give you the b value 17. So 1 times 42, 2 times 21, 3 times, if you don't know, go with the calculator, 42 divided by 3, and it does give you 14. 4 doesn't work. 4 doesn't work. 5 doesn't work. 6 times 7 is 42. So out of all these combos, which combines together to give us the middle value 17? That would be the 3 and the 14, as they are. 3 plus 14 is 17, and that middle term is a 17. So you move on to step 3, which is plug in those numbers into your AX with the parentheses. AX happens to be 3x in this case. And you're plugging in the pair of numbers, the 3 and the 14. Now, we still need to do the fourth step, which is divide each binomial by whatever you can. So the first binomial, you could divide by 3. That'll leave you x plus 1. The second binomial, you can't divide by anything, so you leave it 3x plus 14. Can't divide by 2, can't divide by 3, so we leave it. Now, this is the factored form of this original one, but it's still equal to 0. So you still have the equal 0 here. So now that you have something times something else equaling 0, the first something, x plus 1, that could equal 0. And the second something, 3x plus 14, that could also equal 0. So one answer is going to be x equals negative 1. The other answer, you're going to subtract 14, subtract 14. You're going to have 3x equaling negative 14. Final step would be to divide by 3, divide by 3. So the other answer is going to be x equals a disgusting fraction, negative 14 divided by 3, because you can't divide 14 by 3. You're going to leave it as a fraction, negative 14 over 3. So those are your two solutions to that quadratic trinomial equation. Again, you could have used the quadratic formula, the a value 3, b value 17, c value 14. You could have plugged it all in. You would have gotten the same two answers. Here's a question where they do ask you to use the quadratic formula. By the way, if for some reason you see that the answers are nice answers, no square roots, then you could technically factor, split, and solve. But right here, they're asking us to use a quadratic formula. There's going to be two of these questions on the final. So let's do this. In order for you to use a quadratic formula, or even to solve by factoring, you need to make sure that it's equal to 0. And right here it says equal to 8 plus 5x. That's not equal to 0. So you got to get rid of things. Let's subtract the 5x, subtract the 5x, which you can't really do. 9x squared, take away 5x. You can't really do it, so you just rewrite it. Now you do have the equal sign that did cancel out, but you still have the 8 on the right side. It's still not equal to 0. So subtract 8, and now it will be equal to 0. So you have an equal 0 over here, and let me rewrite everything. 9x squared minus 5x minus 8 equals 0. Now we know that the b value is negative 5, the a value is 9, and the c value is negative 8. And you could plug all that into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's plug in our b values of negative 5 right here and right there. Let's plug in our a value of 9 right here and right there. Plug in the c value of negative 8 right there. Okay, so what do we have here? A negative 5 is a positive 5, plus or minus the square root of, let's find out what the discriminant value is. And you could use the calculator. Let me show you what I'm talking about. I simply typed in the discriminant exactly the way it is right in here. See that? Negative 5 squared minus 4 times 9 times negative 8, exactly the way it is. It gave me 313. So now I'm just going to simply replace the discriminant with that discriminant value of 313. Okay, and it is over 2 times 9, which is 18. Now after that, you're supposed to attempt to actually do the square root of 313. So you type that into your calculator, the square root of 313, hit equal, and you will see that it's exactly that. It doesn't simplify, it stays exactly the same, which means that this is your final answer. X equals 5 plus or minus the square root of 313, all divided by 18. That's your answer. Cool? And there's going to be two of these on the test. So I want to reiterate that when you have a quadratic equation, you could set it equal to 0, and you could factor, split, and solve. But if you see that your multiple choice answers have square roots, then you're going to have to use a quadratic formula. So you could always fall back on the quadratic formula. It always works. Another method of factoring a quadratic trinomial equation or a quadratic equation is to graph it and find the x-intercepts. So if I have, there is a question on the final like this that says, use the graph to determine the solutions of the equation. So we need to remember again that the solutions are the x-intercepts. So if it says use the graph to find the solutions, it's really saying find these x-intercept values. So it's as easy as that. X equals 3, or negative 3 that is, and x equals negative 1 as well. Those are the solutions. There's an actual question like that on the final. It's like free points. I hope you get it.